What I would like to do today in this video is prove the product rule for derivatives, which says that if I have the product of two functions f and g and I want to compute their derivative, then that's going to be equal to f times g prime plus g times f prime, provided that the derivative exists at x for both functions f and g. So let's go ahead and prove it. So the derivative with respect to x of f of x times g prime of x is going to equal the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x, all divided by h. Now, what we're going to do is we're going to add by 0 in a clever way. Mathematicians don't have too many tricks or techniques really that they use when it comes to algebraic manipulation. One of them is adding by 0 in a clever manner, and that's exactly what we're going to do. So we're going to have f of x plus h times g of x plus h, and we're going to subtract by g of x times f of x plus h, and then we're going to add by that same amount. So we're effectively negating what we just subtracted, all right, or what we just added, right? We initially added by a negative. And then let's write down f of x times g of x, and then all divided by h. Now what I'm going to do is I'm going to group those two pieces together, and then I'm going to group these two pieces together, and I'm going to pull out a common factor of, where is it? F of x plus h, and I'm going to pull out a common factor of g of x in the second term, and then I'm also going to split this into two separate limits. So let's go ahead and do exactly that. So what I'm going to have now is the limit as h approaches 0 of f of x plus h times g of x plus h minus g of x, all divided by h, and then plus the limit as h approaches 0 of g of x times f of x plus h minus f of x, all divided by h. Now the next step is we're going to write four separate limits now, because the limit of a product is going to be equal to the product of the limits, provided that each of the limits exists. And I probably should have mentioned up here, the limit of a sum is equal to the sum of the limits, provided that each limit exists, and they do exist. All right. So for the next line of work, we're going to have the following, and you need to make sure I write small, the limit as h approaches 0 of f of x plus h times the limit as h approaches 0 of g of x plus h minus g of x divided by h, plus the limit as h approaches 0 of g of x, and then times the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. All right. So let's look at each piece, starting from right and then working our way left. So this piece right here, and let's pick a different color. Let's pick purple. This piece right here is just f prime of x, because we assume that the derivative of f exists, and this is exactly the derivative of f using the limit definition. this piece right here, this is just going to be g of x because g of x is actually a constant with respect to this limit because there's no h's inside the limit argument. So we're done there. And then for this piece right here, this is the derivative of g using the limit definition. So this piece right here is actually g prime. And then now for this piece, this is going to be equal to f of x as h approaches 0, mainly due to the fact that f is differentiable, and if f is differentiable, then it is also continuous. So as h approaches 0, what's going to happen is that this limit is going to be equal to f of x. So we're going to have the following for our final answer. So we're going to have f of x times g prime of x, and you know what, let's clean that up a little bit, times g prime of x plus g of x times f prime of x, and that is going to be